My name is Nick Koblenz, and this presentation is going to be about the Microsoft Security Development Lifecycle for Agile. Basically, we're going to go through a little bit of background information about what the Microsoft SDL is. I'm going to try not to overlap anything that was mentioned during the keynote this morning. Then we're going to actually talk about what Agile development is and make sure we're on the same page about that. And some challenges that occur trying to implement the classic SDL with Agile software development. After that, we'll dig into the actual Microsoft SDL Agile and why that's so successful for the short iteration type development efforts. And if we have time, I'm going to go into some best practices and tips for increasing the success with adopting the SDL Agile, and hopefully a couple demos. So first, a little bit of information about me. I work for AT&T, and basically I do pen testing, code review, secure software development, methodology improvement, that sort of thing for external clients. On the side, I do some research. In the past, I've done things like I published an ISSA journal article about web application security portfolios. I've created an interview template for the software assurance maturity model, and I wrote a couple articles back in February about reducing information disclosure in ASP.NET Web Services and WCF data services. So when I talk to developers where I'm from, a lot of them tell me that Agile software development and security really don't go together. There's a very big focus on getting functional software produced very quickly, which is really a big part of Agile development. This blog article, actually from Adrian Lane over at Securosis, had a quote that really seemed to sum it up. It just says, Agile hurts secure code development. And what I'd like to do with when discussing Microsoft SDL Agile is kind of prove that point incorrect. I'd like to show how we can actually use security activities during Agile software development, have a conversation with the customer about the importance of those security activities, and actually include them in our efforts. So the classic SDL has been around for quite a while, and during the keynote, a lot was discussed about that. What's new is actually the guidance just for Agile software development. So in November 2009, the new SDL Agile guidance was released, and it focuses on those who produce software in short 2 to 4 week iterations, and gives a strategy for how to include security activities within that process. As for a little background about the Microsoft SDL, as was mentioned earlier, there's a number of development stages and security activities paired with each of those stages. And it's a very rigid process. We do all of our upfront planning and design and architecture, that sort of thing at the beginning of the process. And then when we get to the implementation stage, we're simply writing code against those specifications. During each of those stages, we go through things like threat modeling, attack surface analysis. We go ahead and do code review, those sorts of things, and they're really sort of paired up with each of those development stages, and we can't progress to the next stage until we've completed them. As for the SDL in general, what is it all about? Well, basically, the idea is we want to eliminate any sort of security vulnerabilities as early in our development process as possible. Hopefully through training, security standards and best practices, we can never introduce them in the first place. But if we do, we'd like to identify them in maybe the requirement stage or the design stage. The basic components are things like best practice solutions for remediating vulnerabilities, processes to validate that an acceptable level of risk has been achieved prior to release, standards for specifying a minimum level of security or privacy in the application, security activities to preemptively avoid or identify vulnerabilities, and tools to automate or reduce the effort needed to accomplish these tasks. Microsoft has a number of rules they use to decide whether or not a piece of software has to go through the SDL. These rules are pretty broad. In a nutshell, there are things like if the software is going to be used in any sort of business environment, if it's going to store or transmit personal information, or if it communicates over the internet or any kind of network, it has to go through the SDL. So this basically means just about any software we've ever heard of probably has to go through some sort of SDL at Microsoft. These rules are something that can be used within organizations other than Microsoft as well. So just so it's clear, the SDL is written based on Microsoft's experiences, but it's really something that can be applied to any organization. So we have a couple examples of software up on the screen. So things like Windows 7 and SQL Server 2008 are things that have definitely gone through the SDL. And they actually use a waterfall methodology, or I assume they use a waterfall methodology to produce. And they would probably use something like the classic SDL. Now on other products like Microsoft Office Live or Bing or Windows Live, I suspect that these kind of software as a service type solutions go through a shorter product life cycle, probably some sort of agile process. And in so doing, probably need something a little bit different than the classic SDL. The point of this slide, actually, I'm going to actually do this one a little more quick, is basically the SDL doesn't just focus on security. Things like cross-site scripting, SQL injection, authentication controls are all important, but the SDL also really digs into privacy. So what kind of data are you collecting about your users? How are you storing that data? Do you really need that data in the first place? Do you have a business purpose? And is there any sort of compliance mandates because you're collecting that information? So both security and privacy are important. Okay, agile development. Some folks who've never had an experience with agile development sometimes think that it's just this ad hoc process where you give a development team a bunch of requirements and they just kind of go develop software however they feel like it. They don't have a standardized process or any sort of formal steps. And that's really just not the case. It could be in some organizations, but for the most part, in methodologies like XP or Scrum or Kanban, there really is actually a very structured process that teams go through. Before we really dig into that process, I want to talk about waterfall a little bit more. So waterfall, again, kind of stretches across a long period of time. In this case, I have it showing for basically a year. And again, we're doing all that requirement specification and design and architecture at the beginning of the project. And then we just implement for quite a while. Now, this is not agile software development. We are not just taking the waterfall process and squishing it down into 2 weeks. That's not what we're all about. Really, it looks something more like this. We have a set of user stories, which are really things like a bundle of features and user experience that we're going to choose to implement in basically one go. And we're going to spread it out across a 2 to 4 week period and assign it to developers based on when they get the previous user story done and their sort of availability and that sort of thing. As far as the agile software development process, I'm going to try to talk about it in general. I really can't go through specifics on XP or Scrum and that sort of thing. In this case, I have a diagram of Scrum just because it's easier to talk about. But the very basic concepts around agile software development is we have a set of user stories that our customer is going to go ahead and identify and prioritize. They're going to tell us what's important, what they want done first. And we're going to put all those user stories into a product backlog, which is basically just a bucket of all the things that we have to do at some point. Then at the beginning of a sprint or an iteration, our team's going to look at those priorities on those user stories and the amount of bandwidth they have to get them complete. And they're going to select a subset to implement during that iteration. Now, during that 2 to 4 weeks, the team is going to divide up those user stories, assign them to one or more developers. And then that developer is actually going to go through all the development steps, such as designing the change or the feature, writing the code, unit testing, acceptance testing, deployment, any kind of other steps that are going to be involved. They're going to go through the entire process for that one user story. This process is going to be pretty informal and fluid. We're not going to have a project manager sitting over them going, okay, are you in the design stage or in the requirement stage? Where are you at? We're just going to give it to the developers and assume that they have the skills necessary or can find the skills necessary to complete that user story. At the end of the 2 to 4 week period, we're going to deliver functional software. So this doesn't mean half-done features. This doesn't mean we're going to work on something until it's complete. It means at the end of the 2 to 4 week period, we're going to stop. And then we actually have to demonstrate the software to the customer. We're going to get feedback from them. We're going to ask them, do you like what we've done with this user story? What would you like to see different? Are there new user stories you've come up with? And we're really going to embrace change, new features, removal of features from our project every single sprint, which is also a really big difference between Agile and Waterfall. We're going to be, we have a theme of constant change and welcoming that change. And then basically we repeat this process until the customer runs out of user stories for us to complete and we just maintain the application after that. Now, in these Agile teams, there's a lot of characteristics that are really important for the teams to be able to operate the way they do. Obviously, they're operating fairly independently. They're self-sufficient. So our teams really have to possess or seek out all the skills necessary to complete their user story. So if you have a development team of 5 to 10 people, but none of them knows how to create an Oracle database, they're going to have to go out and not have a project manager standing over them telling them what to do, and they're going to have to go and find a DBA and get help with that sort of thing. The teams, again, are going to have to complete functional user stories in the 2 to 4 week period, which is a very short amount of time, as we'll kind of discuss more when we talk about SDL. And any incomplete user stories are just going to be placed back in the product backlog. And then the teams aren't going to spend a lot of time working on detailed architecture design documents. There's not a lot of documentation really generated, and this is also kind of a feature of that embracing change in Agile software development. We wouldn't want to create some sort of design document when 3 months down the road our application is going to look nothing like it. So documentation artifacts are pretty sparse. So I like to use pictures to further demonstrate some of these ideas. I have 3 pictures coming up that kind of show an Agile team and kind of in their daily life. This picture, I'm guessing, is either a stand-up meeting where the teams talk about what they'd like to accomplish for the day, what sorts of things are stopping them from developing code or completing a user story, and then just talking about general issues. Or this could actually be an informal meeting about what the architecture of the application is going to look like for this iteration. So again, it's very informal. We're going to be standing around this whiteboard, which is kind of our central document, and we'll look at that more in a second. And just kind of have meetings when necessary. This picture is probably the team coming up with user stories and subtasks. One of these individuals may be a customer or customer representative. And we're basically writing down all the features that the customer would like to implement, thinking about how long they would take to actually complete and rating them, and then prioritizing them as well. And we're just writing these down on a sticky note or a note card or something like that. And I'll show you why on the next slide. So this is the whiteboard. It's really the central document for a lot of Agile teams. The really big important part is on the top right. This is kind of a board that lets us know what user stories we're working on for this iteration and how far along we are. In the left column, these are basically the user stories and tasks that we're going to do at some point during this iteration. And as we move to the right, we start looking at tasks that are in progress, tasks that are waiting to be QA'd, and then tasks that are quote-unquote done, which done is a term that each team tends to define kind of on their own. A number of other things on this picture. Top left is a burn down chart, which really shows the team's progress on a particular iteration versus time, which is actually blank in this screen. And then we have a product backlog on the bottom left. Okay, so let's talk about the classic SDL in Agile. This is a diagram from the simplified implementation of the Microsoft SDL. And the reason I put it up here is we have 3 to 6 security activities for each and every development stage. And what I want to demonstrate is it's going to be nearly impossible to complete all of these for each individual user story. We're not going to be able to do a code review and a pen test and a threat model and define security requirements and do every single thing for every single user story. That's just not going to work. Skip that slide. In addition, there's a number of other things that kind of are our challenge for Agile development when using classic SDL. So we mentioned you can't complete all the SDL activities. Our requirements, our architecture, our design is going to evolve over time. So we might find out 3 months down the road that the customer wants to accept credit card payments. Well, that's a really big deal, and we're going to have to adapt to that change and come up with security activities to take care of that. Threat modeling and documentation becomes dated pretty quickly, so we're going to have to do something to either keep the threat model up to date or not use it at all. Just a hint, it's going to be keeping it up to date. We'll talk about that in a second. We won't necessarily know what types of data that we're going to collect immediately. We might collect, social security numbers or other sensitive information, as the application evolves. So we don't really know what kind of protection we need. We may also not know that we're going to talk to some third parties and communicate information to them as well. Another big deal is our development teams are usually pretty small. I would say 5 to 10 developers. So our development team can't include security specialists in most cases. Now we can train developers, we can give them security standards and kind of help them on their way, but we're not going to have a pen tester or security expert as part of our team.